Okay, this is the P1 paper from October 2023. It's question number 10, and if we take a good look at this, we can see this is a trig ratios question. In particular, we're going to be transforming trig graphs here. So before I get started, I need to just remind you of a couple of things with regards to transformations. Our graph is going to be 3 cos and then x over n here. But let's just imagine for a second that it was cos x. I'm going to use the actual graph I've got on the screen here and say if it was cos x, that would be 1 and that would be minus 1. And we know that the period of cos is from 0 to 360. The whole graph goes there before it starts repeating. So if that value there was if that value there was 360, then that would be 180. And so only because this graph's, that point's going to be important later, that point would be 90 degrees on the original cos x graph. But as I say, this is a graph that's been transformed. We have 3 cos x. What does 3 cos x do? Well, y equals a fx. If we ever get that, it's multiplying by a scale factor of a parallel to the y-axis. So in this particular case, actually, I'm going to jump straight in and say, right, okay, so that means that this value here would be 3, and this value here would be minus 3 if this was 3 cos x over n. Okay, but what about x over n then? What does that do? Well, that's another one of our transformations. If we have y equals f ax like that, what that is a transformation. It's a stretch, but scale factor 1 over a. So actually squashes it rather than stretches it. But because we've actually got 1 over n here, we've got 1 over n, which means what we're going to get is this is going to stretch it with scale factor of n parallel to the x-axis. So what that means then is on this particular graph, they've told me what that is here. They've told me that the point that I said was 90, yeah, it's 90 on the cos graph, and I now know this is 270 on this graph. Well, if it's 270 on this graph, then it makes sense that it's been multiplied by a scale factor of 3. So having said all that to you, I'm just going to write down what I would write for the examiner so that the examiner would see my working out. But it's only worth 1 mark anyway. But what I would have said is for cos x over n, that's a stretch scale factor n parallel to the x-axis, which is just really shorthand of what I've just said here. So 90 degrees goes to 270 degrees, which means that n is equal to 3. Now, they only need n equals 3 there, but that's just giving some sort of context to it. Part 2 says what's the period of C1? Well, again, as I'd said originally, that would have been 360 there for the normal cos graph, but if we've stretched this by a scale factor of 3 now, then it's going to be 360 times 3. So for part 2, the period is 360 multiplied by 3, and that gives me 1080. Now, both of those are worth 2 marks in total for that, so it doesn't really matter how much working out you're going to do for that. It's just going to be the actual part to it. Part B says, can we state what the coordinates of this value here are going to be? So, yeah, if we're going through and looking at these, it doesn't matter which way around. Well, first of all, we know that the y value is minus 3, so it's just what have we got on the x values. So what I personally would have done is I'd have said, well, on the original graph, because I know the original graph so well, 90, 180, 270, 360, 450, 540 there. I would know that that's 540 on the normal cos graph, and again, we've stretched it by a scale factor of 3. So if I was doing B, I'd say for Q, we've got that it's 540 times 3 gives me 1,000. No, it doesn't. Gives me, sorry, it's 1620, isn't it? Gives me 1620, and then obviously it's been stretched by a scale factor of 3 on the y-axis as well, or rather minus 1 times 3. So Q is the point 1620 minus 3. Okay, on to the last part then. The last part, I'm going to use algebra rather than using any drawings, any graphs, any sketches here. And it's telling me that if I've got this function, y equals 2 sine x plus k, then this is a point on the graph, and this is a point on the graph as well. Well, if they're both points on the graph, then they're both going to satisfy the equation, y equals 2 sine x plus k. So what I should be able to do is to get a pair of simultaneous equations I can solve. So again, for the examiner now, y equals 2 sine x plus k. And so for the point a 12 over 5, we have that 12 over 5 will equal 2 sine a plus k. And then for the point minus a minus 3 over 5, we'll have that minus 3 over 5 is equal to 2 sine minus a plus k. And I want to solve these two simultaneously, but in order to do that, I really don't want that minus a in there. So this is also reminding ourselves about one of our facts about trigonometry is that sine of minus a is always equal to the minus sine of a. So what that means here is that that second equation can become minus 3/5 is equal to minus 2 sine a plus k. I'm actually going to call that number 1, and I'm going to call that number 2 here, just because once I've got that, hopefully you understand that part of it, then we can just add the two equations together and the sine a's will cancel. So if I now just do 1 plus 2 here, I'm going to get that 12 over 5 minus 3 over 5 is equal to, they will cancel out with each other, is just equal to 2k. So 2k is 9a over 5. Sorry, 2k is 9 over 5. What's putting me off is the fact that that's such a horrible looking 5 there. 2k is 9 over 5, so that means that k is going to be 9 over 10. Yeah, not a very nice question really, but it is question 10 on the paper, so by that stage they do get to be a bit difficult. You might need to watch that video through a couple of times, but hopefully eventually it'll all make sense to you.